Okay, now see in this also body plot. First step I told you, you have to convert it into the standard form. What is the standard form? That in the denominator it should be in the form of 1 plus st1. Correct? So 100 divided by s as 1 plus s1 means 1. Right? Then it is not in the form of 1 plus 1. So to make it in the form, you can take 2 common. So it would be 1 plus s divided by 2. Right? So after solving it, it's how much? 50 divided by s into s 1 plus 0.5. Now your k is not 100. Now your k is 50. Okay. Then in the next step, step number 2, we need to calculate the magnitude at starting point. Right. So formula for that we will have 20 log a minus 20 n log base 10 omega. 20 log base 10. K is how much? We got it down 50 minus 20. N is how much? As you can see, S is in the denominator. S power is equal, S power is 1. So we'll have N is equal to 1 as it's a type 1 order system. Right? So that would be 20 into 1 log base 10 omega is 0.1 because we'll start our graph with 0.1. So after solving it, tell me the value. After solving it, we'll get 54 decibel, right? Our next step is to calculate omega c, right? So how can we get omega c1 is 1 by t1. Omega c1 is how much? 1 by 1, that's 1. Omega c2 is how much? 1 by 0.5, that's 2, right? Remember I told this, its coefficient is 1, right, and its coefficient is 0.5. So our next step, step number 4, we need to calculate magnitude at omega c1, right? So its formula is 20 log base 10 a minus 20 omega c, right? 20 log base 10 k is how much? Tell me. It's 50. Hmm? Minus 20. N is 1 log base 10 is also 1. So after solving, what we'll get? So after solving it, we'll get as 34 decibel, right? Now we need to draw the table, get the next step. So as you know, in the table, we'll write down terms, then corner frequency, then slope, and then change in slope, right? So it is how much serial number term. First term is 1 by j omega, another term is 1 by 1 plus j omega, right? Another term is 1 plus 0.5 j omega. So next is corner frequency. For this one no corner frequency, and for this one corner frequency is 1 by 1, so omega c1 we got it as 1. For this one it would be 1.5, 1 by 0.5, so omega c2 got it as 2, right? Next is the slope. As you can see, it's the denominator, so denominator slope is minus 20. Again it's a denominator, its slope is also minus 20 and its slope is also minus 20, right? Next we need to calculate change in slope. So change in slope is how much? Would be same, minus 20, then minus 20 minus 20 is minus 40, right? Minus 40 minus 20 is how much? Minus 60, right? So basically what we get, the change in slope from omega c1 to c, that we got it as minus 40. right? Yeah. See, now we need to calculate magnitude at omega c. So its formula is, as I already told you, slope from omega c1 to omega c multiplied by log omega c by omega 1, then plus magnitude at omega c1. Got it as 30, right? So slope from omega c1 to c, we already got it, that is minus 40, correct? So minus 40 into omega c2, got it as 2, so log 2 divided by 1, right? Plus 30. Got the same or different? So after solving it, we'll get 22 decibels. So next step we have to draw phase plot, right? So for that, phase plot is how much? Like what was the our was? Yeah, so we got minus 90 because it's a numerator. This was our question, right? So for this question, 50 divided by s into 1 plus s and 1 plus 0 point s, we need to draw the phase plot. 50 divided by j omega 1 plus j omega, then 1 plus 0.5 j omega, correct? So as I told you, if the magnitude is constant, if the numerator is constant, then its angle is 0, right? Then we need to calculate this angle. This angle is how much? As I told you, the formula tan inverse x divided by r. X is the imaginary component divided by the real component. So real component is 0 because we can write it down like this, 0 plus j omega, right? And imaginary component is omega. Now for this one, angle tan inverse imaginary component divided by the real component. Imaginary component is omega, real component is 1, right? Then again plus angle tan inverse imaginary component divided by the real component. Imaginary component is 0.5 omega divided by the real component is 1, right? So anything divided by 0 is always infinity. So tan inverse infinity. And you know what is tan inverse infinity? Can you tell me? Hmm? Tan inverse infinity is 90 degree. Okay. So it's a 90 degree plus tan inverse omega plus tan inverse 0.5 omega. Right? Now if we want to shift it to the numerator side, then can you tell me what would be the final value for this? So if I shift it to the numerator, then we'll get it as minus 90 degree minus tan inverse omega minus inverse zero point 0.5 omega, right? So what we got it as phase minus 90 degree minus tan inverse omega minus tan inverse 0.5 omega. Next step we need to for the table, right? As I told you, in this case we need to put different values of omega so that our phi value will cross minus 180 degree, right? So as I told you, first we need to put 0.1, then 1, then 10. Then at 0.1 you don't need to solve it, I am telling you. It would be minus 90 minus tan inverse 0.1 minus tan inverse 0.5, right? So after solving it, we'll get it as minus 98 point. If I'll put the value of 1 over here, minus 90 minus tan inverse 1 minus tan inverse 0.5 into 1 is 1. Sorry, it is 0.5 into 0.1, right? So after solving it here, we'll get 1 minus 161.6. So if I'll put it, the value of omega is equal to 1.5. Then it will cross it and then answer would be minus 180.2. Okay. So now the next thing we need to draw the plot for this case. Then we'll be able to get the gain margin, phase margin, gain crossover frequency and phase crossover frequency. Okay. So try to plot the graph in your homework, right? Then I'll tell you the next part. Understood? Now I told you everything. You just need to draw the plot. Or should I draw it now? Tell me. Okay. So now we have to draw plots, one for the phase angle, sorry, one for the magnitude and one for the phase angle, right? So it starts from 0, then 10, 20, 30, 40, so on, minus 10, minus 20, minus 30, minus 40, so on. And let's see from the table only. So one of the corner frequencies 1, one of the corner frequencies, right? So our graph starts from 0.1, then 1, then 10, then 100, right? One of the corner frequency is 1, so we can mark this point as 1. One of the corner frequency is 2, so we can mark this point, right? But we got the magnitude at the starting point. We got it as 54 decibels. So 54 decibels is what above. So like some here. Okay, this will be 54 decibels. Then we calculated magnitude at omega C1, right? Magnitude at omega C1 we got it as 34 decibels. So magnitude at omega C1 1, 34 decibels is some here. Is 34. So one point is there. 30. Okay. Then we'll connect it as its slope is decreasing, so it would be minus 20 dB per decade, right? Next we calculated the magnitude at omega C2, that we got it as 22 decibels. So omega C2 is 2, 22 is here, like it's a minor difference like here. So if we'll draw it in your graph, then it would be more clear. Again, it would be minus 20, minus 20, minus 40 per decade, right? So see, minus 20 dB per decade we have drawn, minus 40 dB per decade we have drawn. Next we need to draw for minus 60 decibels, right? So just draw one line in the downward sides, that would be per decade. This is the graph for the magnitude. Next we need to learn the graph for the phase angle. Okay, so for phase angle we'll mark different points. For different omega we'll get different phi. So it is omega, I'm not drawing it properly. Suppose our graph comes like this. Okay, this minus 16. It is always like a curvy shape. Okay, the above one is a straight line like this. The below one graph means the phase angle graph is always the of curved shape. Got it? Now see this, cut it over. This is the gain crossover frequency. Okay, like at this point it cuts, but whatever point it cuts this line, that would be the gain crossover frequency. if we'll draw it in the graph, then you will get grain crossover frequency is 4.45 radian per second. It cut it like here. Then again, this at the point where phase angle graph is cut, that is the phase crossover frequency. So this will, you will get it as 1.4 phase crossover frequency. You will get it as 1.40 radian per second. Okay. Now what we need to do? We need to extend this graph. If we'll extend the graph of phase crossover frequency on the above side, right, it will give gain margin. If I extend the graph of gain crossover frequency towards the downward side, it will give the phase margin. Okay, phase margin you will get it as in negative form, that would be minus 50.3. Understood?